Have you ever wondered how transistors, the building blocks of modern electronics, actually work? In this video, we'll dive into the fascinating world of transistors. We'll explore how materials like semiconductors, conductors, and insulators play a crucial role, how N-type and P-type materials are created. Let's get started. To understand transistors, we first need to learn about conductors, insulators, and semiconductors. Conductors, like copper, allow electricity to flow easily because their atoms have free electrons that move freely. Insulators, such as rubber, resist the flow of electricity because their electrons are tightly bound to their atoms. Semiconductors, like silicon, fall in between. They conduct electricity under certain conditions, making them incredibly versatile for electronic devices. Silicon have 4 valence electrons in its outer shell. These valence electrons are the key to silicon's semiconducting magic, allowing it to form strong covalent bonds with other atoms. In its pure form, silicon behaves almost like an insulator. Why? Because its atoms are arranged in a crystal lattice, where each silicon atom shares its valence electrons with 4 neighboring atoms through strong covalent bonds. This stable structure means there are no free electrons to carry an electric current, so pure silicon doesn't conduct electricity under normal conditions. But things get exciting when you heat silicon. As the temperature increases, the silicon atoms vibrate more, and some of the covalent bonds break. This process releases electrons, creating negatively charged free electrons and positively charged holes where electrons are missing. These electron-hole pairs are the key to silicon's transformation into a conductor. For P-type material, we add elements like boron, which have fewer electrons. This creates holes or positive charge carriers where electrons can jump in. To create N-type material, we add elements like arsenic, which have more electrons than silicon. These extra electrons are free to move, making the material more conductive. Alright, so now we have our P-type and N-type materials. Let's bring them together to form something truly amazing, a P-N junction. When these two materials meet, magic happens at the junction. This is where the foundation of all modern electronics begins. A diode is made from 2 types of semiconductor materials, N-type and P-type. These two are connected to form a P-N junction. The N-type side has excess electrons, while the P-type side has holes or spaces where electrons can go. When these two materials meet, an electric field forms at the junction. Now, let's talk about how to create a PNP transistor. If we take a P-type material, place an N-type material in the middle, and then sandwich another P-type material on the other side, we create a PNP transistor. Now, let's look at the NPN transistor. This one is just the opposite. We take N-type material, place a P-type material in the middle, and then sandwich another N-type material on the other side. This video covered the construction of diodes and transistors. In the next video, we will discuss how these components work in circuits. If you found this video informative, please like and subscribe.